Hello dear students, welcome to Learning Chemistry is Easy and Fun. Structure of Atom Lesson 7. Here we shall discuss further on the phenomena which could not be explained by the electromagnetic theory. Now these phenomena, the first one that we are talking about is black body radiation. What's a black body? A body, as the name indicates, which is completely blackened, right? So when it is blackened, it will absorb all the radiations which will fall on it. So you can imagine it is like this. So it doesn't allow any radiations to escape from it, right? This is what we call as a black body. Now a perfectly black body is difficult to design, so we are taking just a black body with a small hole, so radiations can only enter into it, cannot exit. Now what Planck observed was that this black body, if you heat it, the temperature of this black body decided its color, the color of the light emitted from it. So because it is absorbing all the radiations, it will later on emit as well. The color of this black body on being heated varies with the temperature. So as you keep heating it, first it will be reddish. First you will not see any color. Then slowly it will be reddish. Slowly it will be bluish white in color. So what he noticed was that the color of this black body, perfectly black body, so to say theoretically, is varying with the temperature to which it is heated, or the other way around, when it starts emitting radiations, the color of this black body varied with the temperature. Now when we are talking about the electromagnetic theory, we are saying that the energy of the light beam is only dependent on its intensity. That means it is only dependent on the intensity and not varying with the color of it, right? So how do we explain this phenomena? Second phenomena that he observed was the photoelectric effect. Photoelectric effect, as the name indicates, comes from two parts. Photo is light and electric is current. So when you are generating current or electricity by incidenting light on some material, it is called as photoelectric effect. Now what happens in the photoelectric effect is we've got a metal, we incident light on the metal surface. If we have got a complete circuit connected to it, we notice that current begins to flow through the circuit when light of a certain minimum frequency is incident on it, or when let's not talk about frequency, when certain light is incident on it. So he noticed that when you incident with red light, no, the current doesn't flow. You incident blue light, yes, the current flows. Purple light, yes, the current flows. So if you're talking about Bohr, if you take the red end of the electromagnetic spectrum, the electrons are not emitted, while if you take the blue end of the spectrum, the emission of electrons takes place. How do we explain this? Further on, he also noticed that as soon as you incident light, electrons are emitted immediately. Now here I have not shown the circuit because we are not talking about physics. We are dealing with something which is related to our development of the structure of the atom. But you can very easily observe this phenomena in your calculators, because that is where the light incidented onto the surface of the metal is releasing the electrons, and that is how your calculators, watches, etc. are working. Coming back to this phenomena, so we have first he noticed was that there was no time gap. So as soon as the light was incident onto the metal surface, the electrons were released immediately. Second, that we have already spoken about, you needed a certain minimum frequency of light in order to emit the electrons from it. In other words, there is some threshold that we need over here. The kinetic energy of the photoelectrons emitted. The electrons emitted in this phenomena are specifically called photoelectrons just for name. It doesn't mean that these electrons are in any way different from the electrons that were discovered by JJ Thompson. So the kinetic energy of these photoelectrons emitted is directly proportional to the frequency of the light that you have incident on it. The current that you are getting in the entire process depends on the intensity of light. Intensity means how much of the photons. Now we've not spoken about photons. Let's say we talk about in general terms as brightness. Let's say that. So it will not depend upon how bright or how many of these bulbs you are using. The effect is observed even in vacuum. So what we have seen over here is, let's relate it to your example. You need certain minimum marks to clear the exam. So let's say that is 40%, right? So 40% is the pass percentage. So if you get 40, you clear the exam. Anything less than 40, you don't clear the exam. As simple as that. Now your ranking will depend, your merit place, whether you are above merit, distinction, what you have attained will depend on the marks that you get only after 40. So whether you are an 80% holder, 90% holder, or a distinction or full marks holder will be decided only after 40, right? So what we have over here is that 40 is my threshold. In order to emit the electrons, in order to get you to be declared as pass, you need 40. After that, when we are talking about the photoelectric current will depend on the intensity. That means this 80, 90 full marks will depend upon your level of study, how intense your study is, right? So photoelectric effect was something which could not be easily explained by the classical theory. So was the black body radiation concept. So Planck, he gave his own concept, or he floated the idea of what we call as the particle nature of light. He floated the idea in 1900, and this was further developed in 1905 by Einstein. The gist of that concept, what we call as the Planck's quantum theory of radiation, is we say that radiant energy, any form of radiant energy, be it in the form of heat or light, is absorbed or emitted in the form of small bundles or packets. These small bundles or packets are called quantum. So you can have 1 quantum, 2 quantum, 3 quantum. You cannot have fractions. The quantum of light energy, when we are talking about a quantum of light, the specific term that we use is called as photon. The energy of this photon is directly proportional to the frequency of light that is being incident. So E is directly proportional to nu. Nu is the symbol of frequency. We've already dealt with this thing in the previous lessons. So E is equals to h nu, where h is known as Planck's constant. Here we use it as an approximation of 6.626 into 10 to the power minus 34 joules second. Now if you notice in several literature, you will find as an exact value. H is one constant which has an exact value, but for our calculation purposes, this much is good enough. Why joule second? Energy is in joule divided by frequency, which is per second. So we have this taken to the numerator, gives me a unit of joule second. Photons can be absorbed or evolved only in whole number multiples. So you can do 1 photon, 2 photon, 3 photon. You can never have 1.5 photon. 1.4 photon, 1 3/4 photon, 2.5 photons. No, we can never have photons being absorbed or evolved as fractions. They are always in whole number multiples. Unlike you can do a topic in fractions, right? What this theory says is it has to be done holistically, complete, one. So E is equals to NH nu. The energy carried by a photon is equal, the energy absorbed is some multiple of H nu, that is, a body can absorb 2 photons, 3 photons, so N can be 1, 2, 3 and so on and so forth, never a fraction or a decimal number. Now, coming to our observations over here of the photoelectric effect, there's no time lag. In order to explain this, he said that the atom doesn't need to be heated, or the metal doesn't need to be heated. That is why there is no time lag between the incidenting of the light and the emission of the electrons. Threshold. Simple meaning of threshold is the boundary. Okay, put it in simple normal terms. So boundary. The threshold of your house is your main door. You step out of it, you are outside the house. You put your foot in, you are inside the house. So that's the threshold. Here, in order to emit the electrons, the electron needs some minimum energy. That minimum energy is called as work function. The minimum energy required to emit the electron from the metal surface. So E naught is equals to H nu naught. What is this nu over here? Frequency. Because the energy of a photon is directly proportional to the frequency. So E is equals to H nu naught, where nu naught is the threshold frequency. E is the threshold energy, the minimum energy required to emit electrons from the metal surface. If we are incidenting photons of energy corresponding to E, that is frequency nu, but remember, nu has to be greater than nu 0. It cannot be less. If it is less, what will happen? If the frequency of the light being incident, or the frequency of energy being incident on this is less than the threshold frequency, what will happen? What will happen to the photoelectric effect? Yes, it will not take place. It's just like if you don't put your foot outside the threshold of your house, you're still in. So it will not get emitted. H nu. Nu is equals to nu 0. Then what will happen is the energy is just sufficient. So it is like you put your foot out, you've crossed the house, but you've not moved away from it, right? So in order to move away, in order to walk, you need that energy, and that is the kinetic energy. What is this kinetic energy? The difference of the energy that you have incident onto the metal surface minus the energy that is required to pull the electron away from the metal surface. So what we have over here is the electrons are there on the surface. You incident light, the photon comes and hits it. The electron comes out of the metal, but it hasn't moved. In order to move it away from the metal surface, it needs some extra energy, and that will cause it to move. Now, because the electron is moving, it's having kinetic energy. The kinetic energy of this moving electron is equals to the difference in E and E naught. So, E minus E naught, H nu minus H nu 0. In physics, this E naught is also sometimes written as W. So, don't get confused. We can also write it as W because it is called as work function of any metal. Kinetic energy, half mv square is equals to H nu minus nu 0. So from this equation, the Planck's equation, we can calculate the kinetic energy of the photoelectron being emitted from the metal surface. This goes on to explain why we do not observe the photoelectric effect when we incident red light, but yes, we observe the photoelectric effect when we incident the blue or the purple light. Red light means it has, yes, lower frequency, right? We know from the Vibgyor we did in the earlier lesson, we had higher frequency, lower frequency, lower wavelength, higher wavelength, if you remember. So this red end of the spectrum has lower frequency. This is not sufficient to cause the emission of the electrons from the metal surface. That is why no photoelectric effect is observed. On the other hand, because of the higher frequency, they impart energy which is equals to the work function. Now after this, now if you increase the intensity, coming to the photoelectric current is directly proportional to the intensity of light. So I am incidenting light from blue bulb, but I increase the number of bulbs. So what is happening is I am trying to increase the intensity, right? This is, I am trying to explain to you the difference. So when you increase the intensity of the light carrying that certain minimum frequency, what will happen is the number of photoelectrons being emitted will increase. Whether the electron will be emitted or not will be dependent, they will be decided by the frequency, yes, the threshold, the frequency of the incident light, whereas the current, the number of electrons being emitted will be decided by is also governed by the intensity of light that is being incident onto the metal surface. So this goes on to explain the black body radiation and the photoelectric effect. Now Bohr used these two concepts, or the concept floated by Planck, in order to develop his model of the atom, which is also called as the Rutherford's Bohr model of the atom, because Bohr simply improvised the Rutherford's model. He stuck to the Rutherford's model in terms of the nucleus, but he used the concept of quantization over here. That means giving a fixed value to the energy in order to explain the structure of the atom. We shall be taking it in lesson 8. Till then, very happy time studying chemistry in an easy way. If you like the video, please don't forget to subscribe and share it with your friends, because knowledge is best gained by sharing. Happy studying all of you.